Good afternoon, dear VDMA members, dear industry colleagues, dear participants, friends around the world. A hearty welcome to all of you for today's interactive and interesting web exchange on connecting startups and mechanical engineering for catalyzing growth in this industry. We hope all of you and your families and working teams are all safe and doing well. I am S. Manohar, based out of Bangalore and office of VDMA, and would be taking you forward to moderating this session today evening. It's our pleasure to welcome my dear colleague from VDMA Frankfurt, Dr. Eric Meiser, who is head of VDMA Competence Center for Future Business, Director VDMA Corporate Foresight, and also Director VDMA Startup Machine. I would also like to welcome the speakers or presenters for today's, who are the startup partners for us. Ms. Vani Jans, a senior consultant from Trini Sustainability Solutions. Mr. Avinash, CEO, Resonating Minds. Mr. Nandan Mishra, CEO and co-founder, Algo8 AI. And Mr. Amit Kalagi, CEO and co-founder, Connected Things. Also, a very warm welcome to our own Mr. Rajesh Nath, MD, VDMA India office. Connecting startups and mechanical engineering and bringing startup culture to the mechanical engineering industry has been the mission of VDMA. In this context, VDMA is organizing this interactive session today afternoon between the startups and the mechanical engineering industry. Dear friends, a brief background about VDMA for your reference. VDMA, largest industrial association in Europe. We are 129 years old, started in the year 1892. The entire activities of VDMA is categorized into 36 specialized industrial sectors or verticals within the mechanical engineering industry. VDMA has more than 3,400 members and employees who employs more than 1 million people, and the cumulative production of VDMA members are 205 billion. Very interesting, 78% of the production amongst the VDMA members is exported out of Germany, so that's a big number. We have offices in the BRIC countries, India, China, Brazil, Russia, CIS, and also in Japan, Belgium. Interestingly, from 1st of January, I also understand we started in United States of America. Topics for the discussion today, we would have following this a welcome address by Mr. Rajesh Nath, Managing Director, VDMA India, a keynote address by Dr. Eric Meiser, Head of Competence Center, Future Business and Startup Machine, VDMA Frankfurt. Followed by it would be the presentations by Ms. Vani from we have from Trini, and then we have Avinash from Resonating Minds, Mr. Nandan Mishra from Algo 8, and Amit Kalagi from Connected Things. Thereafter, I would request you all to put your questions in the question bank, question section of this platform, and we would collect all these questions and post it to the concerned person in the question answers of following this, and concluding remarks by our own Mr. Rajesh Nath. Dear friends, we have interesting web topics and also activities organized by VDMA in the coming days. Next session would be on web seminar on photonics. Very interesting topic, because today light is emerging as another method of tool for manufacturing industry, and laser is an important part of it, and we have this webinar on 23rd February. VDMA India office also started its first edition of VDMA India sourcing newsletter for Indian companies and would be published in India February 22. And this publication serves as a valuable source of information of reputed sourcing companies from India. And in case you're interested, do write to my colleague Sabi Andrews. Without any ado, I would like to now welcome our Mr. Rajesh Nath for his introductory talk. Mr. Rajesh Nath is new for the Indian engineering industry, has been strongly promoting the Indo-German relations, has been the face of VDMA for almost more than 2 decades now. He has spent almost 3 decades of experience working in various industries in Germany and India. The most significant of his achievement has been he has been accorded the Cross of the Order of Merit, the highest civilian order from the German government by the President of Germany. Over to you, Mr. Nath.
Yeah, thank you, Manohar, and hearty welcome to all our members and attendees from Europe and India at this very important web seminar today on connecting startups and mechanical engineering for catalyzing the growth in the industry, which is being organized by the German Engineering Federation, VDMA. I extend a warm welcome to our keynote speaker and my colleague, Dr. Eric Meiser, Head of the Competence Center, Future Business and Startup Machine at VDMA Frankfurt. Eric would emphasize on the significance of connecting the mechanical engineering industry to the startups in India for their growth and sustenance, especially in the backdrop of Omicron and Unicorn. A warm welcome also to our 4 startups who will be presenting today: Trini, Resonating Minds, Algo 8, and Connected Things. Friends, this web seminar will cover startups in mechanical engineering, pitching their innovative ideas covering topics like predictive analysis, machine monitoring, ESG consulting, intelligent assets management, and cybersecurity. The Indian startup ecosystem has gained a global platform by stirring up a stormy confluence. India, with 90 unicorns, is the 3rd largest unicorn hub in the world, though we are still well behind US with 487 and China with 301, but are inching close to the century figure, which in itself would surely be a milestone. In 2021, India added 44 unicorns, 2 more than those of the 9 previous years put together. In fact, the government has set a target or is anticipating a possibility of 75 unicorns in 2022. Friends, the speed of technological innovation and the diversity of business ideas keep the startup landscape in constant flux. The innovative approach towards sustainability would bring changes in the process of making products as well as offering services. development of new market areas will emerge in the unserved locations through this process. While many emerging startups are in the areas of electronic and information science, the field of mechanical engineering has huge potential that has yet to be fully exploited. Today's mechanical engineering needs to be well positioned to recognize and seize potential startup opportunities. Startups bring excitement and immense possibilities for the future. India has acknowledged the stark reality of modern business, and its complexity resulted in the emergence of number of homegrown unicorns across the country. In fact, friends, the first ever week-long program was hosted by the Ministry of Commerce, Department for Promotion of Industry and Internal Trade, as the Startup India Innovation Week from 10th to 16 January 2022. This program functioned as a platform of exchange to nurture the global entrepreneur ecosystem, mobilizing capital for domestic investments, providing market access to corporate and government aids, including funding from international avenues. In fact, Eric, you would be happy to know that 16th January has been notified as Startup Day in India. And I think this signifies the resolve of the government to support these startups in India. India's startups enter 2022, friends, from a position of strength. To successfully transform Indian manufacturing industry towards Industry 4.0, it is necessary to build strong technological standard roadmap with a strong economic and social system that can quickly respond to any unprecedented changes in the sector. As Honorable Prime Minister mentioned, our startups are changing the rules of the game. That is why I believe startups are going to be the backbone of the new India, and the golden era of Indian startups is starting now. Hence, friends, we feel the VDMA platforms offers the startups a good opportunity to reach out to the engineering industry and hence contribute towards the new India. I would like to conclude with a quote from Reid Hoffman, who is the co-founder of LinkedIn. He said, "All humans are entrepreneurs." I repeat, all humans are entrepreneurs. Not because they should start companies, but because the will to create is encoded in the human DNA. I wish all the participants an interesting session and would now like to welcome our keynote speaker, Dr. Eric Meiser, to enlighten us with his core concepts on significance of connecting the galloping startups and mechanical engineering industry, which will be followed by the innovative presentations from the startups. Thank you, and over to you, Manohar.
Thank you, Mr. Nath, for enlightening us about the emerging landscape of startups in India. And good to know the 16th of January is the Startup Day for India across. I would like to now welcome my colleague, Dr. Eric Meiser. He's head of Competence Center Future Business in Germany. Also heads the startup machine based out of Frankfurt. He's also the director of competence, future competence in VDMA Frankfurt. In his long career, had several honorary appointments. Now, currently, he is the EU Manufacture Sub-Platform Bio-Intelligent. He's also the chairman. Sorry, he's also chairman of EU Manufacture Sub-Platform for Bio-Intelligent Manufacturing, within known as BIM. Now, it's also had an active role in the industry in 4.0 technology since 2002. His research work in Germany and USA included superconductors, optics, and quantum physics. Eric, over to you, and welcome you across here.
Hello, nice for having me. So thank you very much. It's a great honor and good possibility for me to tell you a little bit about what we are doing at VDMA for startups. And I think this session today is a very good one so that we can really dive into the matter. So we start the presentation. I hope you can see it by now.
Yeah, we can see the presentation. We can see the presentation.
Okay, very good. So yeah, we just start maybe with some numbers here. European machinery in a nutshell, maybe interesting for you. Europe as a big player in the machinery industry, 80,000 companies, 3 million employees, and 730 billion euro turnover. Germany plays a significant role here, as you probably know. And yeah, so that's what VDMA is all about, really being representative and representing this industry. And as you know, Industry 4.0 has been since 20 years a major and big topic for all of us, starting with cyber physical systems and the Internet of Things, going to self-organizing production. And of course, mechanical engineering is not mechanical anymore alone. So there is a lot of electronics and digitalization in there. The last wave being artificial intelligence, machine learning. And the question for VDMA Future Business as a competence center was really to ask the question, what is the next big thing? So the next 10 to 15 years for the industry and what's happening there. So VDMA Future Business started as a competence center within VDMA, really to be a good service partner for you as or for their members, for our members. But we soon recognized that, of course, all or most of the small and medium enterprises in the mechanical engineering industry have basically the same problem we have, because there is a lot of trends out there. It's like a big ocean of opportunities, but a lot of buzzwording and a lot of things you probably don't see at first sight. So point was really to put up some lighthouses here in this big ocean of opportunities, of trends, and try to think ahead for the whole industry, dig out, dive for the new trends, do trend scouting, not only for VDMA to look ahead, but also for the whole industry. And that's why we say we are a think tank for the mechanical engineering industry. And the trend scouting is kind of a helicopter view, what we do there. We have a trend radar consisting of 160 trends relevant for the mechanical engineering industry. And when we find out that there are bigger trends, mega trends out there, important for all sectors of the industry, then we dive deeper into a scenario analysis, and I will show you in a slide what this is all about. And of course, the methodology of how to do this thinking ahead of having foresight as a corporate strategy is the third part we try to achieve here as a service for the members and as a service for the industry. So 3 parts in VDMA Future Business. But one of the big opportunities also for VDMA is whenever we find trends important for the industry, we also ask ourselves, do we have the right groups within VDMA to really dive deeper into the matter here? So one of the things is really to found new groups. And so with the mechanical engineering and artificial intelligence part, we soon found out that our one of our bigger parts in VDMA, software and digitalization, they didn't know in 2015, 2016, when we were founded, about artificial intelligence. There were maybe a dozen companies out of 400 that really knew what this is all about. Today, this is different, but in 2016, it was not so clear. But out there were a lot of startups already doing business in artificial intelligence, and that's why we founded in 2017 Startup Machine. And this way, we think about the trends, but we also implement the future with the startups we have in Startup Machine, and this is the major topic I'm going to talk about today. So maybe a short note on what we have done in future business in terms of the quest for the next big thing. These are the studies we set up here, the topics, the deep dives, and it started with artificial intelligence and machine learning in 2016, went then into advanced materials, also for 3D printing and lightweight production, for example. Climate protection then was covered with power to X, so what you can do with electrical energy, electricity. Hydrogen is already a big part today, so we started this one in 2017. Autonomous supply chain is the question of Industry 4.0, also outside of the factory with drones, for example. Then the question of sustainability was, what do we do with materials at the end of the life cycle? So circular economy and putting that together with Industry 4.0 was the big thing here for 2019. Progressive measuring and testing, big part of the machinery industry altogether. We went into very new topics like quantum technology and biochemical sensors. And last but not least, so study we published in 2021, so last year, was biologicalization of the industry. A little bit big word here, so you have to think about the merger of biology, technology, and IT, what we call biointelligence. And Manohar already told that we have an EU platform here for biointelligence where we push the topic. And of course, biology is also a big topic in India, and pharmaceutical technologies, for example. So you are also ahead of the technology here, and I don't have the time to really go deeper into this topic here. A new tool for sustainability, that's for sure, and we believe this is probably the next wave after digitalization for our industry. Maybe one word to climate neutrality, and as a big topic here, and the role mechanical engineering technologies play here. So 30 gigatons of global CO2 emissions out of 51 can be reduced by mechanical engineering technologies. And so that's a really big lever. And there you can see what mechanical engineering can achieve if the technology is right and the investment is there. But to have also the right ideas and to have the right technologies and the right people, startups are very important here. And we have seen that startups are very important for the mechanical engineering industry in a couple of ways. So they really put trend topics very fast into action, so into new products. And on the other hand, startups have a very different way of working. So that is also very interesting for the mechanical engineering industry. On the other hand, mechanical engineering is a huge user industry for startups, right? And so the point is here that we have basically two parts, a rather conservative, I would say, for the startups, we are a conservative industry on one hand, and on the other hand, the startups that are really applying new technologies and new ways of working. Bringing those two parts together is what we wanted to achieve at VDMA Startup Machine. And point is that, or the big point for the mechanical engineering industry in terms of startups is finding a suitable partner. So since most mechanical engineering companies are SMEs, we found out in the study, and this is what a lot of things I will present here from this study, Strong Together from 2020, only 20% of the SMEs that work with startups afford their own startup scouting. So it needs networks, it needs really a push for those companies, somebody who helps them finding that startup scouting. And this is where VDMA Startup Machine comes in. We do this global startup scouting. I will show you a little bit more in a couple of slides. Furthermore, we try to facilitate partnerships and build those networks that you need for your startup business. And we do member coaching on how to deal with startups and how to do startup cooperation, find out a little bit about the culture and the cultural differences here. So our service portfolio is pretty simple, also 3 parts, same as Future Business. Startup scouting, so where are those startups around the world? And we will hear a couple of them after this talk. Then startup matchmaking, that's the deep dive, right? So after getting an overview, we try to match with startups relevant for the mechanical engineering industry. And then we do this member coaching to really give you an insight what the startups are all about. So diving a little bit deeper into the matter, why machine makers cooperate with startups? What are the interesting parts? And we have done this study. Those are exclusive results I'm presenting here for you. So 84% say products and business models in their core business is why they find startups attractive. 67% is products and business models outside the core business, so getting new ideas, getting new impetus here. And optimized processes, of course, is also one of the major parts here to get in contact with startups. But of course, machine makers also invest in startups, find it good for their image, for example. And last but not least, recruiting talent is also one of the points that are interesting. On the other hand, so if you look at the startups, why do they find it interesting to cooperate with machine makers? 93%, it's not a surprise here, is customer acquisition. So machine makers are a good customer for the startups. Then pilot projects, going into projects, proof of concept is also a big deal here. Reputation, market access, technology and market knowledge for them, and also financial security. So the investment of machine makers is also interesting for them. And question is, what are the technology search fields for the startup selections then? So in which parts of technology are the startups interesting for the machine makers? And it's IIoT, Industry 4.0. That's also not a surprise, but data analytics and AI, it's also a very big deal. And I'm going a little bit deeper into that in a moment. Mechanical engineering technology, so for the machines themselves, automation, but also then additive manufacturing, platform technology, automation, hardware, and logistics. Think about the drones. Is something that is very good here from the technology side for startups and machine makers. So mechanical engineering is an attractive customer industry for startups. Why? So there's a great demand for the products of the startups, as I already said. A catch up in digitalization still. After a long time, digitalization is on. There is still time to catch up in several ways. Access to hidden champions. Yeah, and then there is a lot of technology knowledge around there and out there. Partners that have to be found, and cooperation at eye level means at at the same point of view. And startups this way see machine makers not only as buyers, but also as learning partners. And this is good for both sides, right? So something like top 3 success factors, I'm not going really deep into that slide here, but there is a process how to do that or how to be successful in the cooperation for both sides. So what does each side expect from the other side? What is good if you want to be successful in this whole thing? Of course, you have a process you want to set up, and this is shown in the arrows below. But from machine maker side, the startups think that clear target setting and strategy is very important. Top management support also, right? So it needs the CEOs to say, okay, look, we go into a collaboration here. Involvement of the specialist departments, right? So going deeper into the matter, and realistic objectives is something you should be aware about. And for the startups, they need lean and low bureaucracy processes, a firm budget commitment, and clear contact persons on the other side, right? So, and if you see, the big question is, how do we get to this point? Which startups are interesting for your company? This is what we do with the startup scouting. One of our big services here is what we call Startup Radar, right? So there are landscape reports where we really go into the matter with reports here, navigators through this global startup scene. Of course, mechanical engineering is a global industry with big exports, so it's very important that we look for partners and projects around the world. So not only the startups in the big hotspots like Silicon Valley. Bangalore, we found out, is also a very big spot, and India as a whole for our industry. And with a Startup Radar, there is also the possibility to do deep dives, right? If you're interested in a certain technology like artificial intelligence, then you can check out in the Startup Radar where to find startups for artificial intelligence, for example. We have done that. And then there is what we call the Startup Radar dashboard. So we work together with a Berlin startup that scouts and searches for startups worldwide, with a database of 1.5 million startups around the world. And our point was to really figure out what are those startups relevant for the mechanical engineering industry. And I will show you a little bit detail here. So question is here, it's an interactive startup trend analysis we can do here. How many startups are there worldwide? You can figure that out. Global hotspots, you can see that on the map here. Which technologies are used, founding and funding trends, you can find that out. Then also detailed information on services, financing, and patents. You can do similarity searches. So this is a tool for our members really to figure out and dive deeper into the matter, into special topics. And if you go into the question, artificial intelligence, if you look for startups with AI background for the mechanical engineering, you figure out that there are a lot around the world. You can see also in India, there's a big spot here. And there are 6 innovation clusters concerning AI, so process monitoring, product inspection, predictive maintenance, autonomous factory and process automation. You can see it over here. But the interesting point was that there is a lot of startups in Europe, working for the mechanical engineering industry or with a manufacturing context, and that was interesting for us. That the hotspots are not always the US, you know, so also interesting for you. And if you go into India, you can check that with this tool too. AI is a major trend with 104 Indian startups. We found more than 350 startups altogether in India, and this tool, Startup Radar Dashboard, is really AI based itself, right? So out of these 1.5 million worldwide, they find those startups in a search process with crawlers. So AI really does the job here, because otherwise it would not be really possible to go to that high numbers. And emerging technologies in India, here in India, are ambient intelligence and robotics. Other related trends are autonomous vehicles, automation. So it's a very good possibility to really see startups working with AI in India, but of course you can do the search for a number of other topics. And of course, it's very interesting then to dive into the matter with that tool. So I can only give you a glimpse on what is possible here. So thank you very much for inviting me again. These are the contacts. And yeah, I'm very interested to see the startups presenting here afterwards and what they have to say. Thank you very much. So I think, Manohar, I can't hear you.
Yeah.
Manohar, sorry. Sorry. Yeah, I was quite immersed in your talk. It was very interesting and very impressive, and also giving our members an idea about what exactly are startups, opportunities for them in the mechanical engineering industry, because everybody thinks mechanical engineering industry is an old style. But yes, we have given a glimpse at mechanical engineering, the emerging technologies, and the role as a mechanic as such is reduced, and there's more of electronics and intelligence emerging. So thank you very much for that, Eric, and I'm sure you'd stay across and listen to all our startups who are going to talk, and we would have the questions from all our participants in the end across to you. Thank you very much again. Yeah, so I think we have a poll question today before we have the, right, let me put the poll question across. Yeah.
Yeah, friends. So the first poll question we have for you: the mechanical engineering manufacturing sector needs the startup ecosystem for one of the following reasons: for its growth, talent and ideas, agility and innovation. And the last choice is all of the above. So request you kindly cast your votes, and we'll give a few seconds before you can see the results. Yeah, Manohar, can we close the poll now? So as expected, friends, 75%, the majority of the respondents feel all of the above. That means for growth, which has 3%, talent and ideas 10%, and agility and innovation 13%. So certainly, I think for the mechanical engineering industry, startups can also be very relevant partners. Thank you. And now we go forward with the presentation from the startups.
Yeah. Thank you, Rajesh. We have one second. Let me start sharing. Yeah. We have Ms. Vani, Senior Consultant Trainee, who's going to talk about on the sustainability, and she has more than 11 years of experience and has worked in organizations like Accenture and worked on government contracts with World Bank, USTDA for projects related to the current trends, what she's going to talk about. So it's over to you, Vani, across here.
Yeah, I hope I'm audible.
Yeah, you're audible. Thank you.
Okay, great. Yeah, good afternoon, everyone. My name is Vani, and I am a senior consultant with Trini. So today we'll be talking about how we can digitally enable an organization's sustainability journey, specifically within the manufacturing sector. So you can move to the next slide, Manohar. Quickly talking about the company a little bit. So Manohar, you can move to the next. Yeah. So Trini is a 7-year-old startup and founded by Ankush Patel, who is our CEO and founder. He's based out of the US. Previously, Ankush has had about 14, 15 years of experience at Infosys, where he was leading the sustainability and utilities domain. And Sonata Software, one of the leading IT organizations or the leaders in product development in today's time, have invested about 24% stake in Trini. And this partnership with Sonata sort of gives us the leverage of access to a good skill set for product innovation and their engineering team who sort of take care of product enhancement, adding new features, incorporating artificial intelligence and machine learning in our product, and building new use cases that even Eric talked about, circular economy, carbon accounting, those kind of things. So what we have to offer is basically a SaaS-based platform. It's called Resustain. And so we offer 4 different modules as part of this technology platform: ESG, supply chain, EHS, and CSR. And I'll talk about these in a little bit more detail. On the screen here, you can see some of our notable customers who have deployed the platform and different modules, and they're utilizing it for managing their sustainability related data, reporting on different disclosures, international guidelines, those kind of things. And just a quick snapshot of our team. We have a very diverse set of skill set and experience in technology innovation, product development, domain expertise in sustainability, ESG, CSR, etc. You can move to the next slide, Manohar. So before I jump into the product and the technology that we use to deploy the platform, I just want to cover a few points highlighting why it's important to track ESG and sustainability data in today's time. So, even as Eric was giving his presentation, it's no longer a nice to have thing. It's imperative that we take into account things like climate change and impact of how we are using our resources, how sustainable our operations are. So there are many industry case studies and examples out there that have shown that, how if you are transparent about your sustainability and if you're tracking your resource consumption and managing your sustainability related operations, then it affects your top line growth, right? It results in cost reductions, because if you are finding out where you are over consuming something, then you can also find the opportunity to reduce that overconsumption and cut your costs. Right, then it protects you from regulatory and compliance related interventions in the future. If you're regularly tracking all your safety related data, your employment, environment related data, then you're protected from legal interventions that may come as a surprise, in the future. And we have also seen that today investment related decisions are also being driven by the ESG performance of a company, right? So it's no longer just the financial report or an annual report that talks about turnovers. It's also how well the company is reporting on sustainability related disclosures like GRI or CDP, and how well they are performing on these different matrices. And then lastly, there is also, we have seen a productivity upliftment when it comes to, a more sustainable organization is able to attract better talent. That's the correlation that is being made. So, and then if you move to the next slide, Manohar, we'll quickly talk about, some challenges that are very specific to the manufacturing sector when it comes to sustainability tracking and reporting on different key performance indicators. We understand that the manufacturing sector has a very complex supply chain, right? There are factories, there are distribution centers, there are retail stores, and all these different units are being run by different teams, maybe different third-party organizations, and the data is available in silos, right? And then there are a list of key stakeholders that you can see here that sort of drive the sustainability journey from within the organization, whether it's investors, whether it is international coalitions, like we saw the conclusions from COP26, that now the focus is not just on carbon negative. I mean, it's not just that you are contributing to getting your carbon neutral goals, you're also contributing in other businesses, other countries to achieve their carbon neutral goals, right? There's leadership pressure to attain some sustainability goals like carbon neutrality. Customers and communities are now demanding more transparent information on how a company or even an industry sector is running their operations, how sustainable they are. Suppliers, subcontractors, large organizations like Microsoft, Google, now they are asking for ESG related data disclosures from their suppliers. And within the organization, there are all these silos in which data is available. One team is managing energy data, one is managing water data, one is managing some other utilities, building management systems are deployed. So all this data is in different silos. And beyond the organization, since we talked about complex supply chain, getting the scope 3 emission data from all your suppliers, making sure everyone is tracking, using the same key performance indicators, everyone is reporting on the same indices, all that becomes, a big challenge. And now we are slowly seeing that it's a mandate to start reporting on these things along with your financial statements. Like BRSR has become a mandate, and we have seen evolving guidelines from the Carbon Disclosure Project or GRI. So these things, are sort of the pain points when it comes to tracking sustainability information in the manufacturing sector. So next slide, please. So speaking of the challenges, the solution that we have to offer is this platform Resustain that I talked about. So we offer Resustain as Resustain Enterprise and Resustain Idea. So enterprise is something that is deployed in a larger organization, who wants to start managing their environment, social, and governance KPIs, and beyond that, get into doing a materiality assessment, conducting gap analysis, risk analysis, and finding out opportunities and threats and those kind of things. Resustain Idea is something that is deployed for smaller to medium organizations who are, let's say, just starting their sustainability journey. So again, the technology platform is SaaS-based. It is also accessible through a mobile application. We have built it on advanced open source technologies. It is very easy to integrate and highly configurable. And some of the business values that are achieved through deploying such a technology platform are, of course, like we talked about, having all your data in one place so that you are able to make smarter decisions, quicker decisions. The C-level executives are able to view analytics and dashboards and slice and dice the data the way they want to see it and pinpoint where action is required, right? And then if you have all your data in one place, collated and integrated, correlated with all the different business units that are a part of the organization, then you're also effectively able to communicate the progress on your goals, how you're tracking performance, all that also becomes easier. And then lastly, again, since we're talking about the manufacturing sector, identifying where in the supply chain an action is required, or where do we need to audit more, or where do we need to analyze things in more detail, all that becomes easier to do, with this data management platform. So next slide, please. Right. So I mentioned these modules in the beginning as part of the Resustain platform. So just a little bit more detail about these modules. ESG Plus is, where we integrate all the environment, social, and governance related data. And we set up goals and targets according to the organization's needs, and we conduct stakeholder assessments and find out what is of priority to the organization, and accordingly track progress against those goals and targets. Then we can also, through the platform itself, we can align these different international guidelines, reporting and disclosure templates such as TCFD, GRI, CDP, and track our progress manage our data according to these guidelines, so that tomorrow if we have to submit a report in the middle of the year or whatever the reporting cycle is, we have all that data available in the format that is required and in the templates that is required by these reporting guidelines. Then CSR and social is the module where we are more focused on corporate social responsibility related activities. So you want to manage where your CSR budget is being allocated. What is the impact of the activities that you are conducting under those initiatives? Your employee volunteer hours, employee giving campaigns, and corporate impact assessments is all that comes under CSR. Supply chain is actually an extension of the ESG Plus module, and here we talk about our entire supplier audits, assessments, based on some matrices that we decide on how we want to score our suppliers, evaluation, performance ratings. All of that can be done through the supply chain module. And EHS, which is also very relevant to the manufacturing and mechanical engineering industry, because we are using heavy machinery and we have complex systems that we are working with in factories. Companies want to make sure that there is minimum risk when it comes to employee health and safety, incident management, all your CAPA related activities, all that falls under EHS. And through all of these modules, the core functionality remains the same of aggregating data, integrating all the information in one place, and then creating a strategy and roadmap for future and next steps. Next slide, please. So most frequently, the question that we get asked is how exactly is the data integrated in the platform, and what is the effort that is required from the client side in order to get to the point of integrating everything in the platform. So the answer is there are many different ways to do that. Of course, the obvious Excel integrations and uploading files and CSV files is one. And then we also are able to connect with any legacy enterprise systems that you are already using to collect your environment related data, or your human resources related data, or any governance related information that is being tracked in any other system. We can directly connect through API connectors and extract data from there. Then we also have a functionality called Email Watcher, in which we create a template, and whatever you attach in that template and send in an email, the platform automatically picks all that content up and uploads it in the dashboards. And similarly, we can do that with Google Sheets. So you can move to the next slide. So to quickly summarize, our offering and why it is important to, start this journey if you are still in the nascent stage of it, is that irrespective of, where the sustainability journey of an organization is, our goal with Resustain is to bring to that point of optimizing the data that we already have in different places. It might be in silos, or it might be in one place, to make the data work for us, to be able to create industry best practices, to set ourselves as an example for our peers, to make sure we are communicating our achievements and our goals effectively, making data-driven decisions, and enabling the entire team to integrate sustainability as part of the business and not just something additional that needs to be done, another tracker that needs to be followed, making sure that by using Resustain, everything becomes part of the business, right? Next slide, please. Yeah, so this is just a quick snapshot of what the platform interface looks like. There are about over 50, 60 ways, I think, in which you can configure these graphs, charts, and analytics. And we have access control. Not everyone can view all the data. If you want to set up something specifically, let's say for a C-level executive, they can view that dashboard every time they log into the platform. And yeah, so different ways in which you can, configure all the data analytics, and all your color coding can be done, and all the customization is possible. So next slide. Right. So lastly, just a list of our clients who have deployed Resustain successfully, and are utilizing all the different modules that I talked about. So specifically in the manufacturing and mechanical engineering industry, if we see, we have Advanced Auto Parts, which is one of the leading automotive parts manufacturer and retailer in the United States. They have deployed ESG module, and configured all our reporting and disclosure template module as well for SASB template, and they are managing all of their environmental, social, and governance KPIs through the platform, automating the data integration, reviewing the analytics and dashboards, creating inferences, and driving insights, and making sure that all the right actions can be taken towards the right initiatives. Similarly, we also worked with Office Depot, which is one of the largest suppliers of office supplies in the US, and they also use the platform for materiality assessment and peer benchmarking, and to make sure that they remain industry leaders in their domain. So other deployments of Resustain include Mahindra CIE, Ultratech Cement, Wipro. All of these are some use cases and different case studies that we have with our clients. Yeah, last slide, Manohar. Yeah, so I hope I have not run over my time, but thank you everyone for listening, and would be happy to demonstrate the tool to anyone who is interested or have any more questions. Over to you,
Yeah.
Manohar.
Thank you very much, Vani. It was a very interesting presentation. We do know that with the COP26, ESG is taking up a lot of limelight, and I'm sure this would be a good informative tool. I think we would have questions in the end where Mr. Nath would collect the questions and ask you all in the end across. So we would move to the next presenter across, and next presenter is Mr. Avinash, CEO and Industry 4.0 technology leader from Resonating Minds. Interestingly, he has a patent on this topic of efficient batch processing in a multi-tier application. Over to you, Avinash.
Good afternoon, everybody. It's my pleasure to present in front of you. And my name is Avinash. I'm leading Resonating Minds. And today I will be presenting various offerings and what we have for the manufacturing organization. So next slide, please. In terms of our vision is to leverage technology and engineering for the benefit of the industry, for our own employees, and for the society in general. In terms of the key differentiators, we are focused on the Industry 4.0 technologies, and we have expertise on the machine learning, artificial intelligence, the IoT platform, the machine connectivity, field-based protocols, and embedded technology. In terms of the key areas that we work, it includes the factory digitalization, the remote equipment monitoring, predictive maintenance using artificial intelligence. And we are based out of Pune, India. Next slide, please. We help organizations to achieve their smart manufacturing objectives, and specifically we help for the improvement in the operational efficiency, for the forecasting ability in their business, and the cost competitiveness. So our offerings have been aligned to give advantages on these fronts. Next slide, please. Today in this session, we'll be giving the overview of the four offerings, four solutions. Number one is the equipment machine monitoring or the factory digitalization. Number two is the predictive maintenance of industrial motors. Number three is the utility consumption monitoring. And number four is the part traceability. In terms of the demo, we'll be showing demo of only the second one, the predictive maintenance of industrial motors. Next slide, please. Okay, the factory digitalization. So this is very, I would say that everybody knows the problem statement. So let us still iterate. So typically, let us say in the production plant, the production manager is under pressure to meet his delivery timelines. Typically in a day, he might have the actual production rate running less than the target. Even if there's a scenario, maybe he don't have all the real-time information about the production. He may get all the information by end of the shift, maybe. So this limits his ability to take required corrective actions, and meet the production targets. Sometimes he might also miss out on certain insights about the production. Maybe yesterday night between 2 a.m. and 3 a.m. One of the machine was not producing; it was just running idle. Okay, so this kind of detailed insight he may not have. Okay, and that also limits the ability to improve the production. There are various processes. For example, let us say that say FIS audit or say 4M checklist. Okay, also many other processes. Okay, which are running in the organization. They are probably streamlined, but still they may be paper-based. Now, paper-based solutions, as you know, you can't really do the analytics out of it. You can't make sense out of the data out of it. So and then you don't have the real-time information. Okay, so this is one of the challenge. Okay, the frontline workers they are following the production orders as those are coming, but they may not be empowered to do their job in a right way. They may not have access to the right data at all the time. So this is also one of the challenges. These are the various challenges in terms of the problem statement. We can go to next slide. As a solution, we talk about the factory digitalization platform. So it's a multi-step process. So we can look at each of them step by step and what is that we do there. So number one is the setting up the IT/OT network. Okay, so basically this involves we'll have the equipments, we'll have the machines. Okay, and let us say we can take let us say we talk about the process industry, and we would have the set of equipments. They may be having PLCs from Siemens and various other makes. Okay, so extracting data from each of these equipments, like which are the right protocols to be used. It could be Profinet, Profibus, or which kind of network I should set up. Probably we'll have in the on the other kind of industry wherein we have the CNC machines, and those CNC machines may be say procured in last 10 years. Okay, so the recent machines typically would support data exchange protocols. So in the industry there are various standard protocols like MT Connect, there is OPC UA, there is a FOCAS. Okay, so there are standards, and these machines which are relatively new, they will probably support these protocols. Okay, so when we consider the machines of this category, we need to understand okay, which are the protocols, and we need to extract them. Okay. There is a third category wherein we have the CNC VMC machines, but still those are the older machines. Okay, and those older machines don't support these legacy protocols. So we have to resort to the what are the I/O capabilities those are exposed by the various controllers, and we need to look at that. Then there are other conventional machines like the vending machines, the press brakes, process equipment. So all these equipments we need to typically would like to have the two things. One is the part count, and number two is the utilization. Okay, so we'd like to have these parameters coming from the I/O. So the first step in this is that okay, we identify what are the different machines, what are the protocols. Okay, so that is step number one. Okay, number two is that when we set up the network, okay, there are multiple options. Okay, so the easiest and the straightforward is okay, we set up the Ethernet network. Okay, so with the Ethernet network, we have all the connectivity and we send this data to the controller and server. Now, when it comes to network, other than the Ethernet, we could have the Wi-Fi option, or we could have the 4G LTE. Okay, so sometimes we, the plant is at remote place.
3 minutes to go. Vinash, 3 minutes to go. 3 to 4 minutes.
Okay. Okay, all right. So we set it up the things, and then we have the once we have the network setup, we have the OEE. Okay, so with the OEE, as you know, we will have the ability to do the performance of each of the machine, and then we have the MTTR and MTBF. Okay, the maintenance KPIs. We can go to the next slide. So next slide, please. Yeah. Okay. So this is on the architecture. We skip this at the moment. Yeah, we can go to the next slide. Okay, then important is to set up the digitalization of the frontline workstations, wherein the digital workers should have all the SOPs, the work orders, the digital work orders, all those things have to be digitally accessible to them. All the revision, the data should be accessible to them on the digital workstations. Okay, and then we can have the energy monitoring as well. Okay, we can go to the next slide. So all these steps comprise of the implementation of the factory digitalization platform. Here are certain screenshots which will give certain indication of how things look like. So the first one shows that as the machine is up and cycle time is up, it will show the green. So we'll have the real-time data all time available for entire plant. We can go to the next slide. Here are the quick benefits: the paperless manufacturing, then the improvement in the OE, the empowered management in terms of the right analytics, okay, the frontline empowered line workers, and we have the utility consumption savings. So these are the quick benefits. We can go to the next slide, please. So let us talk about the second offering, which is predictive maintenance of industrial motors. So industrial motors, they drive the critical equipments. If they fail, then there is significant production downtime. So what we have done is, we can go to the next slide. What we have done is that we have analyzed the engineering principles of motors, and we have built the device we call the X-Predictor. It is a wireless and battery operated device. It captures the vibrations. It sits under the motor and it captures continuously the data. On the server side, we analyze this data. We have the AI/ML algorithms, and which continuously run and predict the failure. So basically, we'll have the prediction of the failure of any motor before it really fails, and that obviously it helps for the maintenance heads, maintenance managers to take the required action. They can change it at the right time. We can go to the next slide, please. We can skip this. We can go to the next slide. Let us look at the next offering, which is utility consumption monitoring. The plant heads would like to have the focus on the bottom line as well, and the gas consumption, utility consumption, like gas consumption, the energy consumption, these are the important aspects to control. All that we do is that we connect with the field bus automation systems, and we connect all the data from the energy meters, from the gas flow meters, continuously read the data. And what we present to you is the right analytics in terms of the hourly, daily, weekly consumption, the alerts, and any predictions in terms of anomaly detection. Okay, we can go to the next slide.
Yeah, you have 1 more minute to wrap it up, please.
Sure. On the part traceability, it is for the automotive specifically industry. Basically, it helps you to trace that on when a part is produced from multiple machines, what are the machine parameters in each of this, so that for the compliance perspective, from the recall point of view, from the identifying which lot the part is from. So these are all things which are important, and this is how the traceability solution that helps. We can go to the next slide. Here are quick credentials and some customers. Yes, I think we can go to the next slide.
Yeah, thank you.
That's
thank
all
you.
I think.
Yeah, thank you very much, Avinash, for an interesting presentation. I think you have talked about your platform, which is gives a multiple benefits across. So thank you very much for this. I think we have run off time and there's no time for the video, and I would like to thank you very much, and let's have kindly stay across, so we would have the questions in the end across, Avinash.
Sure. Thank you.
Okay,
Thanks
very much. I would like to now invite Mr. Nandan Mishra. Mr. Nandan Mishra is the CEO and co-founder of Algo, for his presentation on empowering manufacturers through artificial intelligence. Yeah, it's over to you, across, Nandan. Yeah, Nandan is he's a co-founder, and interestingly, he's part of the working group for National Mission for Interdisciplinary Cyber Physical Systems. Welcome, Nandan, and over to you. Thank you.
Yeah, thank you. Thanks a lot, Manohar, and it's absolutely a pleasure to be here. So yeah, next slide. We can move to the next slide. Yeah, so we built Algo8 in 2018 with the vision of empowering manufacturing plants with the right decision making, software that enables them to make the right decisions on optimization, automation, and empowering their workforce on the floor, and also in the end a smart transformation. So next slide. We leverage AI and machine learning to and we learn at a very deep level, from data of each schedule, process, asset, conversations, and also the optics. That's the visual data. So creating algorithms which are like twins of the manufacturing plants. We are one of among the 20 startups which were invested by the Vedanta Spark program. We are also we have served more than 30 clients, and 6 of which are Fortune 500 clients. and we are integrated with SAP and players like OSI Pi and Aviva on the process side as well. Next slide. So what we do, we basically sit on top of the OT, IT, and IoT data that any plant has, and we have algorithms that are helping you with what we call as very smart DDMRP, which is demand-driven material resource planning. I'll show you some examples where we are able to optimize and give almost 15% gains, 10 to 15% gains on planning and scheduling. We also help you improve your availability by reliability by predicting 40 to 100 days before any of your critical machines failure. We also help you with any if you have any many processes on your shop floors, we help you with yield, throughput, efficiency, and quality. And then we also work on many visual analytics aspects. Next slide. Yeah, so I'll just talk about some of the case studies that we have implemented. These are product deployments. So one of our platform which has got a module called Plant Care, which is into smart scheduling and constraint management. So you all must be aware of theory of constraints. So what happens is that you place it in a way so that the constraint is the last, or it is always governing the speed of your process. But what happens is that when you plan and schedule and when you act, the actual data that is on the floor, if you get that and if you start applying machine learning and artificial intelligence on it, you will start to know that where is the constraint shifting in the next 3 days, 7 days, 14 days, and then dynamically manage this. And we are able to optimize and give real-time schedules to plants, which is machine-wise, shift-wise activity in a very dynamic scenario based on the demand and the raw material availability. This has brought about a turnaround for a plant which is roughly around, it has increased 10% of the throughput. When I say throughput, it is sales price minus cost price upon the capacity. So that's the kind of impact that we've been able to do. Anybody interested in this kind of an activity could schedule a demo of this. Next slide. Then we extend this software to the OT data. We've been able to deploy landmark case studies across 10, 20 refineries where these large heat exchanger trains exist. And what we are doing is that we are able to predict the delta T across a heat exchanger train. We are able to predict when will this heat exchanger foul, when to remove it, and optimize the entire changeover such that the heat duty that is getting reduced is also being optimized with the refurbished heat duty that you're getting by placing another exchanger there. So this entire smart management, we have done it for Indian Oil right across 9-10 refineries now. And then we also work on rotary assets, all the critical assets of a refinery. These critical assets are essentially turbocharged compressors, for example, the main air blower of a very big unit. It's a critical machine, and if it fails, as previous speaker said, that it causes a lot of production loss. So we've been able to save around around $600,000 per shutdown. And since the last 1.5 years, they haven't had any shutdown, and they had around 5 in the previous 2 years, and they've given us a written testimony that this has happened for them. And we are able to not only give them predictive prognostic health management around it, but also predictive asset performance optimization around this. And this is for static and rotary equipments of any kind. So we have modules for both. Next slide. Next slide. Then we come on the visual side of things. Many a times we have got a lot of defects in our the products that are being, so there's a lot of pre-dispatch inspection that we do. Also, there is defect at the source. For example, this one is a clear case of weaving. So and we are able to detect and integrate with the PLCs and basically stop the blade before, so that the wastage of the cut piece is reduced drastically. It's almost 3% decrease in wastage, which is roughly $1 million a year for this particular plant. And we are able to give them very, very strong KPIs around quality. So this is the deep learning engine. It continuously learns. So it learns anomalies, it categorizes anomalies as defects based on defects dictionary, and the dictionary is continuously getting updated. This has been done for textiles, being done for zinc industry, for aluminium industry, for iron, cast iron, for a lot of mechanical equipments in automobile manufacturers. A lot of work is being done there. Next slide. This is another interesting case where we are now using deep learning on very simple CCTVs in the plant. So for example, if there is a huge shop floor where we have discrete lines and we have designed them as per TOC, and we are doing the line balancing, and we want to know that, okay, what is the material availability in the particular, what is the throughput there, what is the count of the bags in this case that the person is being able to create, or the inventory throughput through his floor. We are able to discretely count it. We are able to tell that, okay, for how much time was the worker available there, for how much time was the material available there, how many crowding instances post COVID, how many crowding instances were happening on the floor. So all of this we are able to do real time, and generate very nice alerts and MIS for the management. Next slide. So all our capability is very, very deeply integrated with SAP BTP. We are using it to deploy in two of our very large clients, and it also gives us some leeway on the security aspects of things. Otherwise, we have a completely open source stack that we have built. Next slide. Apart from that, we have a very interesting offering around sales intelligence and robotic process automation. So many of you might be having your suppliers and dealer networks. We are able to analyze them, crawl the data from the web, build for you hotspots, more dealers where you can target. How can you enrich your supply chain? Also, what we are doing is that we also tell you that given a relationship and sufficient data, we will be able to tell you the walkaway price, or we will be able to tell you the walkaway price or the premium that you need to predict, that you need to charge for this particular deal. We are able to do that using, again, throughput by constraints as throughput and constraint of your capacity, and the kind of history of your customer fulfillment that you've done for that relationship, and also the competition. You're even using data from the ports, how the custom ports are shipping, etc. That data is also available. So this is another interesting big data use case that we've done. Apart from that, it also analyzes how the emails are coming and how we are responding, what is the relationship level, how is the sentiment. Based on these, we are able to do this, and this has brought about a key differentiator for the client, because he's able to distinguish which order to take and which not. So this is also there. Next slide. Next slide. Apart from that, we are also doing some assembly line, many assembly line deployments. And then actually this slide is slightly muffled up, but it's okay. We are also doing some energy efficiency monitoring use cases as well, but these are not productized, but we are doing it as custom deployments. Next slide.
Yeah, and Nandan, you have another 2 minutes to go, please.
Yeah, next slide. Okay, I'll just completing it. Apart from that, we are also, as I told you, the defect detection algorithm can be extended to packaging. It can be extended to other kinds of assembly lines as well. And apart from that, we are also doing customized sales territory mapping, customized mapping of where for example, for Anheuser-Busch, we analyzed for them how their distribution and how their pricing is working. So this is also done for them. Next slide. Yeah, so more projects across these sectors where we are working on digital twins, etc., working on very, very hard problems where intertwined engineering data is there, and we are learning from that data with first principles and ML. So yes, next slide. Yeah, so that's it. We are very, very keen to solve engineering problems, especially with the application and fusion of artificial intelligence and first principles. We love engineering. I am a trained chemical engineer. My co-founder is a mechanical engineer. And we are data scientists. So we love to solve engineering problems. Yeah, thank you.
Thank you, Nandan. A very interesting presentation. We always now know that data is the most important in mechanical engineering rather than the machine, apart from the machines. So thank you for enlightening us on that, and you were within schedule. Thank you for that, Akroz. Thank you very much. So we have the last presenter of the day, Akroz, not last but not the least, Akroz, and Mr. Amit Kalagi, CEO and co-founder of Connected Think, who is going to give a presentation on industrial data solutions for Industry 4.0. Amit, we have 10 minutes on the clock.
Yeah, can you share the presentation link?
You want to share the screen, correct? You want to run the screen
right.
from here. Yeah, 1 second. Yeah, there you go.
Yeah, let me know if you are able to see my screen.
You can see it. Thank you. We can see it.
All right, great. Yeah, thank you, VDMA, first of all, for this opportunity. My name is Amit Kalagi. I'm a co-founder at Connected Things. We are a company based in Pune, India, and in Germany. And we are into industrial data platform as well as industrial data solutions. For that quick introduction, I will just very briefly talk about our company, but more interestingly talk about the importance of data and data platform and data solutions for growing and scaling your business. Very quickly, this is how our platform looks like. You have, as many of my colleagues and other participants talked earlier, and also what Dr. Eric talked about, there is a lot of data coming from various aspects within the factory floor, within your manufacturing floor, or anything that is there in the industry. And this data is huge. I mean, it starts from process data, operations data, the environmental data, as Vani was explaining earlier, sustainability data, um, and so on and so forth. I mean, audit data, compliance, regulatory. So there is a lot of data that is coming in, and all of this needs to go into a place where it can be processed, transformed, made usable, either for doing analytics sort of applications, or made usable for doing machine learning and AI based applications. So we come in between, where we are building a data platform which can be used for a lot of these use cases, and you can build applications on top of those use cases. So from platforms, here are some of the industrial problems that we are solving. This is a automated doors. So these are a mix of AI, ML, as well as monitoring, operations-based use cases that we have delivered in the past. This is automated door assembly manufacturing, where there are a lot of manual tasks which need to be done on the assembly job, and there is very less digital data that is coming from this. So we provide some AI, video AI-based quality supervision solutions here. We work with a robotic welding process company, where we use noise levels to detect what is happening with the welding process, or is something gone wrong there. We have OEM solutions, where we work with OEMs such as large industrial printers, or rather large industrial printer manufacturers, or autonomous moving robots, just to name a few, where all the process data, all the operations data gets fed to the platform, gets transformed and made available to the management as well as the operations floor to take actions based on that. Moving on, specifically just focusing on the manufacturing part, we deliver multiple applications, connect to various machinery through PLC SCADA, through gateway, through industry protocols which are available on the manufacturing floor. All of this data gets fed to our platform, and we deliver specific analytics applications on top of it. Just to name a few, the use cases are in monitoring, where we have downtime monitoring, OEE, which is one of the important factors for industrial efficiency, or even safety and health related monitoring use cases. Predictive maintenance, predict multiple things, essentially, sorry. Predict the system health, predict the tool health, predict remaining useful life of a tool, do log and search data. So you have millions of lines of logging and text that is fed to the platform, and you need to search across that, search your manuals, and all of that needs to be automatized. So all that is possible through the platform. And of course, video ML based use cases and applications, where we have developed a few ML supervision applications, which I will just touch upon in a couple of minutes. Here are the solutions for data solutions specifically tuned towards OEMs. We have delivered solutions for autonomous moving robots, very large industrial printers, which generate a lot of data, and a few solutions in assets and power tool around tracking and logistics. So all of this data gets fed to the platform, One of the core things that you can understand from this is a lot of process data, which means that the data is available as process started, a lot of events coming in and process completed, and you need a view of this entire thing that has happened, number of jobs that have happened, number of tasks that have taken place in the previous day, which have passed, which have failed, how long has been the machine idling. All of those kind of use cases are very critical for OEMs, for themselves as well as for their customers. And on the right side, you can see we also have a BI dashboard kind of system where you can build very customized dashboards for each of your use cases. One of the strong points of this platform is all these are fully customizable based on your business case, and it is just a matter of configuring and enabling new use cases on the existing platform. Moving on, this is another use case that we have built. This is around AI supervision, where we have assembly floor, where there are a lot of manual tasks being done around assembling a specific part. One of the key challenges that many of you might be aware is once the part is done, let's say a door assembly is complete, there is no way to inspect what has gone inside or what is the quality that you have gotten. So once this is delivered to your customer and 6 months it has been used, then if there are defects, then you get a return, and that's a major challenge for many of the OEMs in this industry. So one of the ways in which this could be done is there is a camera-based system, as you can see here, which is mounted on top of the workstation, and in this it is just monitoring hand movements and trying to figure out whether a certain process has been followed and what is the kind of process score that you could give to a particular job. Now, the benefit of that is that you will know then and there if there is something that has been missed, and you can go back, review it, correct it, and you can save a lot of money, especially when the tools are expensive, the tasks are expensive, and they are used for a very long period of time, such as metro rails and those kind of equipment which are manufactured. Some of the key USPs of the stack, I would not really spend a lot of time here, but think of it like this. I mean, it's a data platform which is built to scale. Do not think of data in terms of few MBs and something that you can open in Excel or something. Think of terabytes together of data, right? You will realize that this needs to scale. It can't be built with just one particular vertical or one particular application in mind. It has to scale for each application. You need to be able to move on and build multiple applications as your business grows, as new use cases come, as new business logic come into that you need to deliver, right? So we at the core, we are built to scale. The platform is built with various technologies like Kafka, Presto, Docker, I mean, of course, to name just name a few. And we are built to scale to very large data size. At the core, we and our founders come from a telecom background. We understand security, data privacy, regulation, and these are very important for us. And we deliver specifically to enterprise customers in this industrial area. Moving on, I would just like to again emphasize the importance of data. I have around a minute to summarize. So these are the use cases that you probably have already heard of. Predictive maintenance, smart factories, energy management, asset tracking, how do you optimize OE, how do you do AI supervision and computer vision. We can deliver many of these use cases on our platform. And what you need to look at specifically is how do you get business outcomes from all of this, right? What are the newer business models that you can enter into in service-based models, e-mobility, many of them. How do you get autonomous AI-based factories where you don't have to do a lot of tasks manually, you don't have to do a lot of driving or operations manually. How do you optimize supply chains, logistics, and so on, which is inventory management. So all of these are very critical for your bottom line and top line costs. Very important is how do you build sustainable business and sustainable solutions, right? How do you monitor your CO2 footprint? How do you ensure that the material that you're using is properly recycled? Where is all of that data coming in, and how are you managing all of that? And one of the key things that came up recently is personalized customer experiences, right? So if you think of automobiles have moved from being vehicles to services, right? So you have Ubers of the world, you have Olas of the world coming out with very, very different models, and these are customer experiences. These are no longer vehicles and products. So those are the business outcomes that we can enable you to deliver. Digital transformation is where we help with, and think of digital transformation as a multi-step process. It's not like you can do one thing and you're there. What we would like to emphasize is you need to start with a very strong data platform, and that is where we can come in and help with you. We are happy to understand any of the problems that you have and work with you to build very, very specific solutions. Thanks to all of you, and thanks to VDMA for this opportunity. Thank you, Manoj.
Thank you very much, Amit. Thank you. It was a very interesting presentation, helping to connect various machines and devices to a common platform and get data and analyze it across. Before we move to the question and answers, and Mr. Nath takes over, we have the last poll question for the day. I would request all the speakers to come on camera, please, presenters and Dr. Eric also. 1 second.
So friends, the next poll question: the startups are keen to design and develop product services applicable to the mechanical engineering or manufacturing sector for, and you have the option, its potential for huge growth opportunities, applicability of wide spectrum of technologies like Industry 4.0, easy adoptability of technologies by the industry, and none of the above. So friends, you have the chance now to do your to do the selection, and we'll give it a few seconds before we close the poll. Okay, Manoj, can we close the poll now? So friends, let's see what is the view from our participants. So they feel the startups are keen to design and develop products applicable to the mechanical engineering manufacturing sector for its potential for huge growth opportunities. And then in the second position, there is a applicability of wide spectrum of technologies and easy adaptability of technologies in the industry. So thank you friends for participating in these poll questions, and also I would request all our participants, also the attendees, you're free to post your questions, and maybe I would request first Eric. Eric, do you have any questions for our startups who have presented?
Okay, so nice for me because I can use the microphone and don't have to type in things. Yeah, I think question to Vani. Is she in?
Yeah,
Vani,
I'm here. Yeah, I'm here.
Right,
I'm having some bandwidth issues, so I'm going to keep my video off.
Okay, no problem. So I think scope 1, 2, 3 for sustainability and CO2 monitoring is very important, and scope 3 is very hard, right? So you always have to check across your whole supply chain. And I found it pretty hard for machine makers because they are somewhere in between, right? So they are suppliers and they have suppliers for themselves. So how is the sharing data a point there, right? So people are sometimes not so keen on sharing all their data. How does that affect your platform? And this is also probably then a question to all others for the AI, but especially to Vani for the CO2. Are people aware of the CO2 problem, and are they keen on sharing their data? What is your experience there?
Yeah, thanks for that question. That's a great question, Eric. So I'll answer it in two parts. So yes, there is definitely more awareness comparatively than it was a few years back about how imperative it is now to, you know, report your emissions and, you know, track all your consumption of natural resources. The awareness has grown, but it probably isn't at the point where it has become a regular business practice to report, you know, on these key performance indicators. So we are not at that point where there's a team defined to identify, you know, where the challenges are, where the gaps are, where the overconsumption is. So that is where the platform comes in, and we have a very, you know, structured way of figuring out what the organization boundary is, what falls under scope 1 and scope 2, which is, you know, direct emissions from what the organization is using, and what is a supply chain slash scope 3 emissions, which is coming from, you know, the extended suppliers, third party vendors, and the companies that we work with. So the platform is able to identify that boundary and, you know, calculate the emissions accordingly, because each of these type of emissions have different back-end calculations. We have to gather some emission factors from EPA or IPCC, and then, you know, calculate the emissions and impact accordingly. So yes, the platform has the ability to, you know, categorize these different type of emissions and create your analytics accordingly. So I hope that answers your question.
Pretty tough job, because we have recognized at VDMA that the awareness is sometimes not very high, right? Among customers,
yes,
and among suppliers, and also among the machine makers themselves, actually.
Yes, you're very right about that.
Yeah, maybe a simple question to Avinash. User interfaces. You said you save that paper scribble a part of a factory, right? So what kind of user interfaces do you have for people to put in their data, or is that kind of automated?
Right. So basically there are 2 or 3 kind of user scenarios are there. For the management, of course, it is a web interface. It is accessible from your tablets, your PCs, your mobiles, and everything. Okay. Then for the frontline workers, we have 2 kind of things. One category is that sometimes the HMI is available on the machine. Okay, so we have the HMI thing. But more often nowadays we are supporting the web-based for the frontline workers as well. The advantage of the web-based still for the frontline as well is that, of course, the layout we make it you know, larger fonts and you know, easy to key in. Okay, but still it is a web interface, because then, you know, it is very easy to have all the server data on the platform, which is a little challenging with HMIs. Okay, so for in a nutshell, it is a web interface. Only thing is that based on the role, how the look and feel of the application for them, it changes.
Great. So maybe a last question to all of you from the AI part. As a user of AI, I have seen that AI is not always very reliable. You always have to also put your human intelligence in, right? And so how do you manage that? How do you get your huge amount of data you need for training? So Nandan, you have your cyber physical systems there. You have your cameras, Amit. So it's very nice work. But how reliable is that all in all? And also question to all of you: how do you handle data security? So that sharing of data is always a big question. Amit put that on top. But maybe question to all of you, and then I'm out.
Right. So I think, Eric, that's a great question. So I think when we think of reliability of machine learning algorithms, we know that machine learning, if we think of the major class of machine learning algorithms, they are usually probabilistic and not deterministic, right?
Yeah,
The
that's right.
Bayesian might be deterministic, but the rest of them are probabilistic. So when we think of, even when you take up, I often give the example of Google Maps because I was a part of that Google Maps team in India when we were deploying this traffic API. So the traffic algorithm always gives a probability. If you look at it, if you, for example, forecast it, it'll say it'll give you a time from this minute to this hours to this hours. But when you use it real time, it gives you a precise answer. So what happens is that it's always a curve, it's always a curve, and the prediction is the median. So the challenge is this uncertainty. If I give the user that, okay, this quality is going to deviate from 92% to 96%, now it's of no use to him, right? So I have to basically give him the quality as one parameter and the confidence on that quality as the second parameter. So I'll have to manage it at that level, and then I basically see that, okay, yeah. So then I have to see that how the source data can be changed to get a thinner and thinner thing. But again, it is probabilistic. So yeah, so it was one major problem for us in one of the user acceptance. I remember in one of the refinery petrochemicals, where we were predicting the quality output of the polypropylene that we were manufacturing, and the lab was saying, no, you have to predict 95, and we said, no, it cannot be 95. Even you have tolerance. How can we? So that was a big debate. But yes, we reached to an answer that, okay, if it is directionally correct, and if it is serving my purpose, then the machine learning can be reliable. So there will be scenarios in which we can trust it.
Mm-hmm.
So very, very true, Nandan. I mean, we also face this huge problem of where do we get all the data from, right? What we have seen in the past is the approach to machine learning and AI needs to be slightly different than the traditional software. Machine learning is like human intelligence. It's like a baby. When it's born, it grows, it evolves, and it gets to, I mean, if you look at some of the photo detection on Google Photos, it's marvelously accurate. I mean, it's hugely accurate, right? But they didn't get there on day one, right? So the approach to machine learning should be that you get and you start with something. It gives you some level of confidence and accuracy, and as you feed in more data, you feed in more of human intelligence into that, it'll get better and better as you go ahead. So the approach needs to be slightly different than looking at it like a normal software, which gives you, okay, yeah, it's a logic, it's true, it's not true. That is one part. Just to answer the second part of what Dr. Eric asked, security and regulatory is a very, very major concern. We have been working with a lot of customers. So one thing what we saw is even although, I mean, we understand a lot of necessity of being on the cloud and using all the platform as service offerings, all of that, right? There is still a lot of concern about data going out of your factory premise, and
exactly.
There is no easy solution for that. But what we enable is hybrid and deployments which are very easy to do, which can be even put in on your edge within your factory, or they can scale onto the cloud if there is a possibility to do that. So yeah, very, very important part. The security and regulatory things that come in might become a challenge to digital adoption at a very fast rate.
Yeah, so thank you very much. I love the applications you've shown, right? So this gives you already a very good view on how this all works. Thank you.
Yeah. Avinash, would you like to say a few words also to the earlier question?
Yes. So one comment I would like to make is regarding the data. Okay, so one of the challenge that we see is that, let us say that we are talking about the industrial motors, and how do we do the there are various faults that any typical motor will come across. Okay, so now from where do you get the data set? Because to set up the, let us say, my bearing fault, or let us say rotor status, there is a eccentricity. Okay, so if you try to set it up in the lab, that itself will take 6 months of a time, and you're not very sure whether you have simulated it right or not. Okay, so a lot of times what we had to do is that we had to analyze the theoretical patterns of the vibrations, and we had to generate the data which will simulate, okay, this is the data and this is the theoretical explanation. So little bit help of the theoretical background of the problem statements is always, it helps, because on day one the customer expects that I put the motor and it has to tell you the fault. Okay, customers are not ready to tell that, okay, let me learn and then I will tell you. Nobody wants to wait for that. So there has to be certain faults to be predicted upfront based on the theoretical knowledge, whatever the AI engine has built, and as the time progresses, it has to learn with the new data. So it is a little, I would say, it's a hybrid model of the theoretical knowledge as well as the machine learning. That's how at least we are doing it.
Yeah, so that's the reinforcement learning part of machine learning, and you start with a probability X, and you get better and better, same as Nandan explained, right? But I think other than the traffic and the internet data, face recognition cats on the internet or whatever, the sheer amount of data for machines is not so large. And so you need customers that are willing to share that big amount of data. And without that, you have no learning. Without that, your AI algorithm doesn't work, right? So it's a difference between machine maker algorithms and the data for that, and the everyday use of Google Maps for traffic data. Huge difference, right?
I think for machine makers it is an advantage because they have the machine, so they are in control of their own data. So they can store the data and they know, okay, what are my makes, what are my models, and they can correlate to the data. So I would say it is advantageous significantly. And with their own data sets, with their own machines and their own parameters, so it is more feasible to have the predictions compared to very diverse, and you don't know the data sets, and you go to the customer with very diverse data sets. So compared to that, this is much I would say easy. It's not very difficult, but it's good problem to solve in that way.
Yeah, for the machine makers, it would be nice to really have have AI algorithms for their whole customer base, right? And usually you only work with one machine maker and one customer. For lasers, for example, you would be interested in your whole install base around the world, and this is sometimes, from my experience, hard to achieve.
Right. So thank you, Eric, and thank you to Avinash, Amit, Nandan, as well as Vani. I think we had some excellent presentations, and it was really very interesting, and I'm sure our participants today would have gained a lot also from these presentations. So let me just conclude today's session. A few words on the present scenario. The lockdown and I think the social distancing has pushed several businesses to shift from conventional methods to entirely digital-driven operations, thereby creating better avenues for market forces. Leveraging new age technologies such as artificial intelligence, data analytics, big data, several startups are working towards bridging this wide-ranging gaps that were introduced in the market. Though we are moving in the right direction, however, the regulators have to play a more proactive role in formulating appropriate regulations that encourage innovation and support emerging startups. And they need to foster a conducive climate for ensuring easier availability of domestic capital. I'm wishing everyone a good start to the year 2022. And despite of the challenging circumstances we are presently facing, let us have faith and confidence that we shall overcome and come out of this present crisis stronger and better. So friends, stay connected with VDMA. Do follow us on our VDMA India LinkedIn page to get regular updates on our activities. And thank you everyone for joining us today. Stay well, stay safe everyone. And thank you Eric and Avinash, Vani, Amit and Nandan, and also Manohar. Thank you for the excellent presentation. Stay well.
Thank you.
Goodbye. Take care.
Thank you.
Goodbye.
Thank you, everyone.
Yeah, bye.